Lesson 6.6. Solve exponential and logarithmic equations. There are two methods to solve exponential equations and two methods to solve logarithmic equations. Method 1 for exponential equations is that if the bases are equal, well, the exponents have to be equal. And that's because exponential equations are what's known as 1-to-1. For example, let's do page 334, number 3. Well, these bases don't look equal. But maybe they are. Because 25 is 5 squared. So I could rewrite it like that. And then we have an exponent, parenthesis exponent, which says I should multiply those exponents together. So it'll be 2 times x minus 5. And now the bases are equal. Therefore, the exponents must be equal. And then just finish solving. Distribute. Combine like terms. And finish solving. So it looks like 7 is x. Which of course we should check by plugging it back in. If we plug in a 7, we'll have 5 raised to the 7 minus 3 and 25 raised to the 7 minus 5. And you can see both sides give us 625. So that is our solution. Why don't you try this one? Try number 1. The answer is -1. Method 2 is the general method, so this is the one that works all the time. Method 1 only worked if you could write the bases the same on both sides of the equation. Problems like this one on number 9, you can't do that. So we'll take the log of both sides. We do that because the log cancels the exponential. It's the inverse of the exponential. Just like a square root is used to solve a squared problem because the square root cancels the square. So the logarithm cancels the exponential. So the first thing we'll do here is get the exponential by itself. We'll get rid of the 5 to get this exponential part by itself. And now that the exponential part is by itself, we'll take the logarithm of both sides, and I could choose any base. But I'll choose base 7 because that is what the base of the exponential is, and it'll cancel out. So it's like you use a square root to cancel x squared, you use a cube root to cancel x cubed, you use base 7 to cancel base 7. And now just finally divide by 5, so it's log base 7 of 12 over 5. All right, you'll probably have to use the change of base formula to put it in your calculator. So log of 12 over log of 7, and then that divided by 5. So I'll bring my calculator over. So I'll have log of 12 divided by log of 7, and then that divided by 5. Which you can see is about 0.255. We should check our answer. So 5 times 7 raised to the 5 times our answer is 60. Hey, it worked. Why don't you try number 11? Pause while you solve it. The answer should be about 0.173. To solve logarithmic equations, there's two methods again, like there were for exponential, and they're essentially the same thing. The first one is if you have the same log on both sides, so like on number 17 here, I have the same logarithm on both sides, then the stuff inside the logarithm must be the same. Again, this is the one-to-one property. It's not that the logarithms cancel out, we just notice that, oh, hey, they're the same. So the stuff inside the logarithm must be the same. Get the x's together. Divide by the -3, and you have 4 equals x. Of course, we should check that. So if I go ln 4 times x was 4, minus 12. So on that side, I get 1.386. The other side, ln 4 is the same thing. Why don't you try number 19? The answer is 3. All right, solving logarithmic equations. Method 2, exponentiating both sides. It's making both sides exponential because exponential and logarithms are inverses. Thus, to get rid of a logarithm, you have to do exponential. So let's try this one, number 21. We can't do method 1 because there's no logarithm on the right side, so we need to get rid of this logarithm. First of all, you make sure that the logarithm part is isolated. It is. And then we will take the base of the logarithm and make that the base of both sides. So I'll have 2 raised to everything that was there equals 2 raised to everything that was there. The reason why we do that is because the exponential base 2 and the logarithm base 2 cancel out, leaving the 4x plus 8. And 2 to the 5th is 32. Subtract the 8, so 4x equals 24. Divide by the 4, so x is 6. All right, let's check. All right, since it's base 2, I'm going to use the change of base formula. Or maybe I'll just use the option in my calculator. So I can do a log base 2 of 4 times x, which is 6, plus 8, and it gives us 5, just what we were expecting. Why don't you try number 22? The answer is 4.